All right, so hey everybody. Today we're going to be asked to find the area under the curve with subintervals of equal length. This is also known as the definite integral. So that can already be replaced with an integral sign. We're also given an interval, so our lower bound is 1 and our upper bound is 5. The integrand, which is our function being integrated, is x squared plus 2x plus 3, and it will be respect to x. So now we can evaluate our integral here and then write it with an evaluation symbol. So the integral of x squared, so this is like the reverse power rule. So we're going to add 1 to the power. So our power will be 2 plus 1, and we're going to divide it by our new power, which is 2 plus 1. That will just be 3, all right? Hopefully that's not news. Okay, so with our next one, we're going to do the same thing. Remember that our definite integral has an additive property, so we can just add them together at the end. So what we have, we can just integrate the whole thing, or we can do it one by one, and it's a lot easier to do one by one. I think that's probably the only way too. So this x has a power of 1 on it, so we can add 1 to the power to give us a new power of 2. Then we are going to divide by the new power. Before we move on, I notice that the new power that we're dividing by and the coefficient in the original will cancel out, will divide out, excuse me. So for this one, so it's just a 3. However, we know this, we remember we talked about way back when that anything to the power of 0 is 1. So we can pretend that our 3 is basically 3 times x to the 0. So now we are able to apply a reverse power rule. We can raise x to our new exponent, which is our old exponent plus 1. So we're going to add 0 plus 1 to get 1, and we're going to divide by 1, which I didn't really have to write. But picturing this as x to the 0 can help us with that. So we're going to be evaluating this. This is still generic. It's a definite integral, so it definitely has a value. So what we're going to do is we're going to evaluate this at our lower bound, x equals -1, and our upper bound, x equals 5. So what we're going to do now is we are going to plug in the values for when x is equal to 5, and then this is going to have a value. Then we're going to subtract for when x is equal to -1. So let's go ahead and have a go at that. So we're going to plug in x equals 5 everywhere. So we have 5 cubed over 3 plus 5 squared over 1. I didn't have to write that. Plus 5 squared plus 3 times 5 as our integral evaluated at our upper bound. So now we're going to evaluate at our lower bound. So we have 1/3 plus 1 minus 3 times 1. We should have our -1 here. This will also be negative due to our odd exponent. This had become positive because of the even exponent. So let's evaluate within our brackets first. So we have 5 cubed over 3. We have that will give us, actually we're missing a 2 here from our 25 from 5 squared. So this will be 125 divided by 3. And if we notice that 125 cannot be divided by 3 to give an integer. So we're going to write all of our numbers in the first set of brackets with the denominator of 3. This will give us 125 plus 75 plus 15 times 3, which is 45. All right, so this will all be over 3. Then we have our second set of brackets. We have 1/3 plus 1 minus 3. So we have -1 plus 3 over 3. Well, -1 over 3 plus 3 over 3 minus 9 over 3, because 9 over 3 is 3. So this will give us two fractions that have a denominator of 3, which we can add later. I'm going to keep them separate for now so I can do some math. So we have -1 minus -9, which gives us -10. If we add 3 back to that, that's -7. So when we subtract a negative, that gives us a positive. So now I can add the numerator, since we have the same base in both fractions. So that will give us 252 divided by 3. However, we're not done yet, as I wouldn't know this off the top of my head. I know that 252 is a multiple of 3. All right, so without a calculator, well, with a calculator you can get the number for this. But to check if a big number is divisible by 3, one trick you may or may not know is you take the sum of the digits in the big number. 2 plus 5 plus 2 is 9, and you check if the sum of the digits is divisible by 9. So, I mean divisible by 3. So when I take the sum of the digits, I get 9, which is divisible by 3. So that means this is divisible by 3. So now you can go through and find you can find a way to divide without your calculator to give you the simplified form for this fraction, which does end up being an integer. So I did not go through, I didn't really, well, I was taught long division when I was young, but I didn't really take it with me. So I'm just going to use the STEM guess something, I don't know what it's called. I forgot to hit pause recording. So what I learned when I was young, I was taught long division, but I do go with the partial quotients. So I'm going to pause the video and work through it, and then get back with the final answer. I apologize for the random minute-long gap. All right, so that would be the answer.